All right, we're in lesson 24 today, and today is the multiplicative property of equality. To demonstrate the multiplicative property of equality, I have to think really hard and focus to say that word. We'll begin with the true equation, 2 equals 2, and multiply both sides by 3. So if we multiply this side by 3, and we multiply this side by 3, both sides are equal to 6. So it remains true. So that's part of our, if you remember our rule from lesson 23, whatever you do to one side, you have to do to the other side. And that includes multiplication. So here is the statement for the multiplicative property of equality. If A equals B, then AC should equal BC. And this is the multiplicative. I really don't like that word. It's so hard for me to wrap my head around sometimes. Property, I'm just going to shorten that. It's property of equality. And it's so much longer than the illustration to write it than just to show it. So if A equals B and you take some other unknown number C and you multiply both sides, it remains true because you did the same thing to both sides of the equation to keep it balanced. That's all it's saying. It's saying that it is not only is it true for addition and subtraction, it is true for multiplication as well. All right, let's solve problem 24.1. We have 5x equals 20. So if 5x equals 20, then that must mean that the 5 is multiplied times some number to get 20. So we have to ask ourselves, how do we undo that? What is the reciprocal operation or the inverse operation? It's division, right? So we can take this factor of 5, because it's 5 times x, and undo it by dividing 5 here and dividing 5 here, because we have to do the same thing to both sides. And because we're multiplying and dividing by the same number, they cancel each other out. We factored them out. So x is by itself. 20 divided by 5 is 4. And that is correct. You see how easy that was? You guys can do this in your sleep, I have no doubt. All right, here's one that's a little bit harder. 24.2. What happens when we have a fraction times our variable? We have 2/5 x equals 7. Well, we just have to think about it the same way. We are using here, we used the inverse operation, the reciprocal. So now we have to use the reciprocal here. And the reciprocal of this fraction is 5/2. So if we multiply 5/2 times both sides, we'll turn this into a fraction by putting it over 1. Then this factors out, and we're left with x equals 7 times 5 over 1 times 2. So 7 times 5 is 35. 1 times 2 is 2. This is the answer. And this is where you stop. You do not have to turn into a mixed number. Just leave it right here. That is the final answer. Okay? You don't have to take it further. In fact, I prefer that you leave it like this. Unless the question specifically says to reduce it into a mixed number, the only reducing I want you to do is in factoring. All right, so let's do 24.3. I think I have room here for it. We have 2 and 1/4 x equals 3. Okay, all right. I hate mixed numbers. I'm just going to go ahead and say it. I can't stand them. They totally mess up the whole flow. So whenever you have a mixed number next to a variable, turn that joker into an improper fraction. So 2 times 4 is 8, plus 1 is 9. So we're going to say 9 over 4x equals 3. Now we can do the inverse. We can do the same thing we did here over here. So all we have to do is flip-flop it over. That's a technical term, flip-flop, not just the things you wear on your feet. And then we'll multiply over here by the same number, 4 over 9. These two will cancel. We bring down our x. And now I say 3 times 4 is 12. And 1 times 9 is 9. We can reduce this because both of these are divisible by 3. So that's going to equal 4 over 3 because 12 divided by 3 is 4 and 9 divided by 3 is 3. So x equals 4/3, and that is the correct answer. See how we got there? We hate mixed numbers with variables. Always turn those into improper fractions, okay? Unless I specifically say not to, turn them into improper fractions because you just get an easier number to deal with. So much easier to deal with a fraction with a variable than it is a mixed number to variable. It's just less confusing. All right, we have 2 more problems. So let's clear the page. So we're going to do 24.4. And 24.4 says x over 3 equals 9. Okay, Miss Tracy, I don't know how to do this. That's what you're thinking, I know. X is part of the fraction. Before it was next to the fraction, now it's part of the fraction. This is not right. Okay. Slow down and think about what you're seeing. What you're seeing is x divided by 3. So what do we have to do when something is divided to cancel it out? We do the inverse operation. So we are going to multiply by 3. Okay? That's all we're going to do. So we're going to say 3 times x over 3. We're going to make that a whole number, put it over 1. And then we don't have to do that over here because this is a whole number, so we don't have to turn it into a fraction. So we're multiplying both sides by 3. These cancel. Okay, we are left with x over 1. X divided by 1, anything divided by 1 or multiplied by 1 is just itself, right? Remember, a whole number over 1 is just the whole number. Same thing here. X over 1 is just x. X equals 9 times 3 is 27. Does that seem really big to you? If it does, check it. This was x, right? 27 is x. If you take 27, you put it back into your problem up here. If you said 27 divided by 3 equals 9, if you do that, if you divide 27 by 3, the answer is 9. So x is the correct answer. 27 is the correct answer for x. All right? Just think about what you're looking at. Think about what is that operation. It's division, so the opposite is multiplication. Let's do one more. 24.5. This is our last problem. It's a little bit of a doozy. I don't want to throw you for too big of a loop, but we do have a mixed number. So we've got to get rid of that. And it says x over 2.5 equals 7. Oh, and we have another one that goes along with it. And that one is p over 3/2 equals 4 1/3. Well, let's just see what we can do. Let's start with this one. So I hate mixed numbers, so we're going to undo that. 2 times 2 is 4 plus 1 is 5. So x divided by 5 over 2 equals 7. All right, so remember how we talked about a fraction, which is a division problem, and what we do when we have a fraction divided by a fraction? We keep it, change it, flip it. So we could just rewrite this joker. X divided by, right, 5 over 2. Doesn't that look easier already? It does. And all we have to do is put this over 1, and now we have two fractions, and we can do keep it, change it, flip it. So we do x over 1 times 2 over 5. Okay, so 2x over 5 equals 7, right? So we're going to keep working this out. All we have to do is use the reciprocal. So 5 over 2 times 2 over 5. And we're going to multiply this over here too. Make this, I don't know why I'm writing crooked. 5 is going to cancel out. 2 is going to cancel out. Goodness. I am writing crooked. So x is going to equal 7 times 5, which is 35, over 1 times 2, which is 2. Okay, and that's the correct answer. All right, so let's look up here. We have the same thing. It's just a division problem, y'all. Don't get stressed out. We're going to write p divided by 3 over 2. Okay, and I hate mixed fractions. We're going to put that back. 4 times 3 is 12, plus 1 is 13. So 13 over 3. All right, that's the way I want that. All right, now we're going to keep it, change it, flip it. So p over 1 times 2 over 3. That's going to be 2p over 3. Flip it and multiply because we're going to use the reciprocal. But we have to do the same thing over here. So 13 over 3 times the reciprocal, which is 3 over 2. Right? This cancels. This cancels. We factored them out. So we're left with p all by itself. 13 times 3 is 39. And actually, we don't even have to do that. You see what I see? We have a 3 here and a 3 here. Those 3's cancel out. So our answer is 13 over 2. How about that? That was easy. So look for that whenever you're doing your multiplication of fractions. If you've got one on top and one on the bottom, just like over here where they canceled out, you can cancel them out over here too. Now we couldn't cancel out both of them because we needed an answer. But we could cancel out the 3's. I was about to multiply this times 3 and this times 3 when I caught it. I would have just had to turn around and reduce by 3. So I saved myself a step by not doing the math and factoring. Okay, so I hope that you're getting the hang of this. If you're not, I can always give you some more practice problems. Just give me a holler. Or I'll walk you through it if you need some more clarity. But that's all I have for lesson 24. And I will see you guys in lesson 25.